My name is Dave McConnell, and I'm founder, president of this company. And getting into this type of technology, I have a lot of background from offshore drilling, deep water exploration, and various other industries. We built a turbine, but the turbine has only got a capacity factor of 42% to 45%. So we went into this hydrogen. Now, this hydrogen is a little different concept than the nuclear people are using. We go ahead and we extract the atmospheric pressure from 14.7 down to -0. And our engineers, they even took it, Dr. Medinsky and Ted even took it farther than that. And this is the extraction, taking the atmospheric pressure out of the core. In here is the core that produced the steam for the turbine. This here is what we call a blast housing. So when a core, if it ever explodes at the temperatures and pressures we had, this would seal people from the explosion, and the explosion would go out the diverter to the atmosphere. I'm going to get back to some of this other here. This is the header from the core, and like I mentioned, this hydraulic extraction system, we only did it 9 strokes per minute. On our other 500 kW to our 3.5, it's going to be much bigger, like 8 times larger. And on the 3.5 megawatts, it's going to be 12 times and bigger. This here header is all schedule 220, high pressure, high temperature. And out the end there was out to the sensors. The sensors is what told us that we produced 40.2 kilowatts at 54 horsepower. And out there, it read the flow, PSI, the temperature, and that give us the 40.2 kilowatts. That's 42 kW. And that's how we got our parameters to go into the bigger one. This year, Ted has explained all this, our engineer, he explained all this here. The temperature in here, when the valves would start leaking, was 760 PSI. And the temperature at that time was 355 degrees Fahrenheit. So when that started to leak through all our valve systems, we shut it down, and this was when we were commissioning, and that was in October of last year. And now we're going on to the big cores and the 400 kW. Well, this one we're building will be actually a 500 kW. And the pressures on that one will be very high. And our engineers have already calculated that will be, we brought in a steam turbine for the big one.